Hello friends, welcome to my YouTube channel Maths DNA from origin to infinity. This is my 11th lecture on real analysis. In this lecture, we are going to discuss about questions on sequences. Let us begin. Example 1. Consider the open interval -1 to 1 and a sequence an of elements in it. Then the options are every limit point of an is in the open interval -1 to 1. B. Every limit point of an is in the closed interval -1 to 1. C. The limit point of an cannot be -1, 0 and 1. And option D. The limit point of an can only be -1, 0 and 1. This question was asked in Csir-Net June 2016 Part B. Now let us solve the question. We will solve this question by giving counter examples to each of the options. Solution. For option A, every limit point of an is in the open interval -1 to 1. And option C, the limit point of an cannot be -1, 0 and 1. Let an equals to 1 minus 1 by n. Here, as n tends to infinity, an tends to 1, which is a limit point which does not belongs to the open interval -1 and 1. Therefore, we get option C and option A are false. Now for option D, the limit point of an can only be -1, 0 and 1. Consider a constant sequence an equals to 1 by 3. Then 1 by 3 is a limit point, and so we get that D is also false because we got a limit point which is other than -1, 0 and 1. Now the only remaining option is B. So the correct answer is option B. Example 2. Limit n tends to infinity 1 by root n into 1 by root 2 plus root 4 plus 1 by root 4 plus root 6 up to 1 by root 2n plus root 2n plus 2 equals to. The options are A. Root 2, B. 1 by root 2, C. Root 2 plus 1 and D. 1 by root 2 plus 1. This question was asked in Csir-Net December 2015 Part B. Now let us solve the question. Solution. Firstly, we rationalize the numerator and denominator. That is, we multiply the terms with their respective conjugates. 1 by root 2 plus root 4 is multiplied and divided by root 2 minus root 4 and so on. So we get limit n tends to infinity 1 by root n root 2 minus root 4 by -2 plus root 4 minus root 6 by -2 and root 2n minus root 2n plus 1 by -2. On solving this equation, we get limit n tends to infinity 1 by root n root 2 minus root 2n plus 2 by -2. The alternative terms get cancelled out, that are -4 plus 4 minus 6 plus 6 and so on. Taking n common, we get limit n tends to infinity root n by root n root 2 by root n minus under root 2 plus 2 by n divided by -2, which is equals to minus root 2 by -2, which is equals to 1 by 2. Therefore, the correct answer is option B. Also, a similar question was asked in a previous year. That is, limit n tends to infinity 1 by root n 1 by under root 1 plus root 3 plus 1 by root 3 plus root 5 up to 1 by root 2n minus 1 plus root 2n plus 1 equals to. The options are A. Root 2, B. 1 by root 2, C. Root 2 plus 1 and D. 1 by root 2 plus 1. This question was asked in Csir-Net June 2014 Part B. It is similar to the previous one we solved, but here the terms are 1, 3, 5 and so on. Now solution. Here we again rationalize the numerator and denominator by multiplying with the conjugate of denominator, that is multiplying by under root 1 minus root 3 upon under root 1 minus root 3 up to root 2n minus 1 minus root 2n plus 1 by root 2n minus 1 minus root 2n plus 1, which gives us limit n tends to infinity 1 by root n root 1 minus root 3 by -2 plus root 3 minus root 5 by -2 up to root 2n minus 1 minus root 2n plus 1 by -2. On solving this, we get limit n tends to infinity 1 by root n root 1 minus root 2n plus 1 divided by minus 2. The alternative terms get cancelled, and now again taking n as common, we get limit n tends to infinity root n by root n 1 by root n minus root under root 2 plus 1 by n divided by minus 2, which gives us minus root 2 by minus 2, which is equals to 1 by root 2. And therefore the correct answer is again option B. Thank you, and get the best material for preparation by just one click. The link is given below in the description. Also check out other 30+ videos on my channel.